Hi everyone, welcome to the Quad on Enzymes. The instructions tell you to label the parts of the diagram and then below use this diagram to explain how structure affects function. The first thing I'm going to do is clarify that this point over here is the start of this reaction, and then this point over here is the end of the reaction itself. So there's a couple of things that hopefully you've noticed. The first is that this dark structure is at the beginning of the reaction and also at the end of the reaction. That means that this structure is the enzyme, because an enzyme will not get used in the chemical reaction. So I'm going to use the letter E to represent the enzyme present at the start of the reaction, and then also the same letter E to represent that the enzyme is present at the end of the reaction. This little drawing right here shows substance going into the enzyme. Therefore, this must be the substrate. Don't worry about these little circles. They're left over from a different activity. And the substrate goes into the enzyme in these little pockets, and these little pockets have a name. That is the active site. So that is going to be the part where the substrate will bind with the enzyme. So your enzyme plus your substrate will form a temporary unstable molecule that is where they are joined. This unstable, what we call intermediate, so it's in between substrate and product, this unstable intermediate is called your enzyme substrate complex. They are joined together. This is where the chemical reactions will take place. And then what you are left with are the products of this reaction and the enzyme that is now free and able to be used again. In this particular example, you'll notice that the substrate was joined, and then what comes out, the products of this enzymatic reaction, are two separate pieces. So we had a polymer, and we've now made two monomers, meaning that this enzyme did the process of hydrolysis. Hydrolysis, if you will remember from Unit 1, requires the input of water, H2O, to break a polymer into individual monomers. And judging by the shape that they've given you, this is probably a polysaccharide, a disaccharide, a carbohydrate, which means that these would be the monomers of carbohydrates, which are monosaccharides. Now this particular enzyme, because it's breaking products, it's doing the process of hydrolysis, is referred to as a catabolic enzyme. And I just tell students to remember cats tend to break stuff, or like cat bulldozers will break down things. So cat means that they are enzymes that break down. Down at the bottom, it's asking you about how the structure of enzymes will affect their function. If you change the structure, they will most likely no longer function. And that process is called denaturing. There are two ways in your video that you learned, or in your flipped homework, that you learned about the process of denaturing, and that includes going beyond the optimum temperature. In other words, above the temperature or below the temperature. And then another one is pH. So above the pH, the optimum pH, and below the optimum pH. But another one that we can include is your ion concentration. All of these will denature your enzyme. They will alter its shape, and most of the times this results in an enzyme that doesn't function correctly. Usually you can see this process. If this is my rate of reaction, and this is, let's say, pH, temperature, this right here represents your optimum. And then anything beyond this range, you're going to get decreased enzyme activity to the point where the enzyme will no longer function. So enzymes are a great example of how structure affects function. I'll go ahead and zoom out just to go over it one more time. Enzymes are not used in the process of the reaction, but they do help to speed up chemical reactions. And I'm just going to put RxNS for reactions. The substances that go into the active site are known as substrates. What comes out are the products. And these enzymes can be affected by environmental factors such as temperature, pH, and ion concentration. Thanks for watching.